Now, one of the most powerful, one of the most useful skills you will gain in maths is the idea of being able to construct and use formula. Because when you leave school, nobody does anything on paper. That's the truth. I mean, we might sketch ideas, but you want to be using a computer to do serious calculations, and the idea of mathematical modeling becomes really important when that is the case, where you can build a formula and then you set up the formula in, for example, Microsoft Excel, and then let the computer do the number crunching, the calculating aspect of it. So the ability to model a problem using algebra, making a formula, is very, very important for more advanced mathematics work. And so it's one of my favorite areas, really. Let's look. The talk through here is about this idea of using the perimeter, and how we came up with this formula for perimeter, and we looked at that, but I'll pop it up again one more time anyway. I think it's that useful. So if we have the rectangle, I'll just put two rectangles, and we model one. We know this is a length. Sorry, this length here. We have a width, then we have another width, then we have a length. Then the perimeter, which is the distance all around, can be perimeter is equal to L plus W plus W. So the two L's plus the two W's, and we agreed that we can I'm adding the same number twice. I'm writing down the same number twice and adding, so that's multiplying by 2. Where we don't put the multiplication sign in algebra, we'll just write 2L. And similarly, I'm doubling the width, so 2W. So P is equal, the perimeter is equal to double the length plus double the width. That's what we've written down there. That's what's presented in text looking nicer than mine. So you can read through that one as well. And then if this is the length and this is the, sorry, I keep mixing it up. I don't know why, but if we have the width and the length, the area is the space inside a 2D shape, the area is the length multiplied by the width. Okay, so the examples there of how we can build formula. We're building models, a model of formula for finding the area of a triangle or finding the perimeter of a triangle. I'm saying triangle, but I'm looking at a rectangle. So finding the area or perimeter of a rectangle is what we're looking at there. Let's build some of these formula for ourselves. We'll build them together, and then you'll have some questions to try. Let's look at this one where it's asking us to find the perimeter of the shape, and it's given us, and then to work out a formula for the perimeter, and then to use that formula to find the perimeter. Now, I know you'll probably look at this and want to jump in putting in the numbers to actually get what the perimeter is, but you need to practice building the model. The benefit of building the model, building the formula, is that when the values change, A, B, and C change, it can easily be updated in terms of you getting the answer when you have a method of when you have a formula. So in this case, P, the first way you would write it for A is P is equal to, remember, perimeter is distance going all the way around. So I need to total all those numbers. So A plus B plus B plus A plus C. And what we would want to do is to simplify that expression. We've done work on that previously. So A plus A is 2A, B plus B, that's 2B plus C. So the perimeter of the shape, 2A plus 2B plus C. That's the formula for the perimeter of the shape. Now, we are asked now in part B to find the perimeter given specific values for A, B, and C. That is where substitution comes in. So for part C, and I'll just rub that off, for part C, part B now, it is too early in the morning. That's what's happening for me. Part B, woo, is going to be 2A. P, I can write it again. P is equal to 2A plus 2B plus C, which in our case is 2 multiplied by 2, A is equal to 2, plus 2 multiplied by 3, B is equal to 3, plus 5. Those are the figures we should have. And 2 2s are 4, 4 3s are 6, 5 times 5 is 5. Sorry, what am I doing? 1 5 is what I have. 6 and 4, 10, and 5, 15. The perimeter is 15 centimeters. That's what we're coming up. If you did it and I'm saying your way, but if you didn't set up the formula, you would have just gone 2 Plus 3 is 5, plus 3 and 2 is 5, and then another 5 for C, giving 15. But as I said, if I change the numbers, I said, okay, now A is 7, B is 8, C is 13. As we keep changing numbers and more complicated, complex, it becomes problematic. So using a formula and substituting in the formula using the computer, forming that formula to substitute using the computer, that's a very, very, very powerful strategy. Let's move on. Let's go on to, I have it as P0. It says worked example, but what's the formula for this? What's the formula for the engineer's charge? What are you going to come up with? Pause, have a go at it, see what you come up with. Pause and have a go, please. Right, so what I would want to have a C for charge. C is the engineer's charge. And note it has a basic fee of 20. So whether he does anything or not, whether he spends half an hour, 5 hours, 20 hours, he's still going to get that 20 pounds. So that's the basic charge, a fixed amount, which he will get, and he or she will get. Wow, I can't believe I'm doing that. He or she will get regardless of how long they work. And then the rest of time, and I'll put H for hours, I can model it as plus 8H. Okay, right, because if he works 1 hour, it's going to be 8 times 1, 8 pounds he'll get. If it's 2 hours, 8 times 2, 16 pounds she'll get. If it's 3 hours, 8 times 3, 24 pounds he will get. If it's 4 hours, 8 times 4, 32 pounds she will get. You see the switching? He, she. I'm thinking about it. So that deals with how much they're getting per hour for the repair work. But then we know we need to add on to 20 pounds the basic charge, and that's what we have there. The basic fee, sorry, that is going to be the engineer's charge. The engineer's charge is the basic fee plus the amount of money earned per hour, which is 8 pounds at a rate of 8 pounds per hour. So that's what we're looking at there. I've given you enough ideas, I think. I think really this is one of the questions where you want to just get stuck in. I've done a couple together. Let's get stuck in. There's 10 questions we're going to work through. You're going to work through. Where for some of them they're reasonably interesting that I might put some additional commentary, but in general it's the answers I'm going to provide for these 10. There's not a lot more. Once we have this idea of substitution and forming and in terms of we know what expressions look like, so we want to put them together based on experiences we've had. We should be fine. Let's do it. Let's go. We're presented with 2 diagrams here to find the area. One is a triangle, part E. Part D, it's a compound shape. How do you find the area of a compound shape? How would you deal with that? How would you write? What's the formula you would use? Because remember, we want you to write the formula first and then do the calculations. Try and write the formula first and then do the calculations. And I know I have to say that because if I don't do that, then you'll just revert to probably just doing the calculation without building that algebraic model that's so important as a skill, as I said at the start. For D, you want to split, so you pause, you had you go. I'm doing it now. Or if as I start to go, you get your aha moment. So the split is that your aha moment. Then now you can pause and you go through it. I will call the bottom A. I'll call the top bit B. And then the overall area, I know I can't use A because I want to use A for area. So I will call B and I'll call this C. And then for area, it's going to be the area of B, so A multiplied by B. That's what the area of B is going to be, A multiplied by B. And I'm going to multiply that by the area of C, and that's going to be B multiplied by C, B multiplied by C. So plus B multiplied by C. I almost wrote the multiplication sign. Don't need it. It's algebra. Now, can I do any work with this? No, we're done, really. If you want to factorize it, you can. You don't have to, but they do have a common factor, B. And if we pull out B, we have BA plus C. So that's another form that you can put your answer in. Now for the second part of the question, remember it's not just finding the formula, it's also actually using the formula to work out an area. So the area, if I use in this particular case, I use my brackets, B is 4, and A plus C would be 3 plus 9. We need to do what's in the brackets first. 3 and 9 is 12. What the number outside the bracket, remember expanding, we need to multiply out. So we're going to multiply 4 by 3 plus 4, and multiplying 4 by 3 plus, I'm saying 3 plus 4, 3 plus 9, 3 plus 9. What's going on with me? 9 and 3 is 12, 4 3s are 40, 12 3s are 48. So your answer for the area for D is 48 centimeters squared. Finally, for E, and the hint I will give you, because I know everybody forgets it ever so often, the rectangle, I would say, is what fraction of the triangle. Sorry, the triangle, wow. The triangle is what fraction of the rectangle. So I'll say that again. The triangle is what fraction of the rectangle. And what you have, AB, is the triangle is going to be half. So the area of the triangle, if you did not remember, is a half. It's base times height, but in this case, it's going to be a half A times B. So half AB is what's going to give you the area of this triangle, because AB, if I multiply the length by the height, I would get the area of the rectangle. And what we're seeing here is that the triangle is half of the rectangle. The triangle is half of the rectangle. So we can do this. We can use this formula. We have, doing our substitution, a half multiplied by 4 multiplied by 5. 5 fours are 20. Half of 20 is 10 centimeters squared. So a half AB, half of the area of the rectangle. The area of the rectangle would have been AB in this case. Half of that is the area of the triangle. That's what we substituted in. Let us move on. That's question number 4. Let's do number 5. And we're moving away from diagrams now. And you have these questions to read where we want to read word problems and form expressions. So that's where we don't have the equal sign. So for example, I can form a expression x plus 2x plus 3x plus 5x and so on and so forth. And then when we put it's equal to something is how we create a formula. That's the interplay between these two. I'm waiting. Pause. Have a go. You have a go. Lovely. You've had your moment. Now it is for me to go through this idea with you. And 3 consecutive numbers. This comes up a lot in proof, etc. Advanced maths. Consecutive numbers. Consecutive, it's one after the other, and what we need to be thinking about is integers. They should have probably put integers. Consecutive integers. And when we have integers one after each other, say if I started with 2, then the next number would be 3, and the next number would be 4. And how can we generate those? Well, what did I do? I added 1, and if I want that's to go from 2 to 3, I'll go add 1. And if I want to go from 2 to 4, then I'm going to have to add 2. And that's the logic. We're not starting at 2, but in this case we're starting with x. X is the smallest number, we're told. So what are the other two? If the first number is x, first number is 2, what do I have to do to get the next number? And then the next consecutive number, add 1. So I'm going to use x plus 1. And then the one after that, it will be x plus 2. Because what we had was 2 plus 2. We did the 2 plus 1 is 3. We did 2 plus 2 to get 4. Okay, so that's the logic. Those are the numbers. Now write down the formula for the total of the 3 numbers. We're going to have t is equal to x plus 1 plus x plus 2. That is what we're looking at there. And then we can simplify that because we can collect like terms. We have x and x and x, which will give me 3x. And then plus 1 plus 2, which will give me plus 3. So 3x plus 3 is what we're looking at as a final answer, and you can see how we got to that. Let's move on with some more number work. I think it's more words, more word problems. Number 6. Consecutive numbers again. Nope, we don't need the consecutive numbers. This is number 6. I got it right there. We're talking about the mean. Now, do you remember how to find the mean of a set of numbers? And what if the numbers are letters in this case? How would you represent the formula for finding the mean? Off you go on that one. See what you'll come up with. Okay, so you had to pause. You went through it. To find the mean, the idea with finding the mean is you add up all the numbers you have and then divide by how many numbers you have. So in the first one, for A, M is the mean. I have two numbers, x and y. I'm going to add them up, x plus y, and then I need to divide them by how many numbers I have. And in this case, I have two numbers, so m plus y divided by 2. For the next question, we have P, Q, R, S, and T. So that's 1, 2, 3, 4, 5 letters. So M is going to be P plus Q plus R plus S plus T divided by, wow, I didn't need to put that, divided by 5. Wow. Divided by 5, that will be the second mean there. So here is number 9 for you to try. P9 I should say, because for some of y'all this won't necessarily be number 9, depending how I've cut it up. So you're just following the order, the sequence. P9 is what you're looking at there. Path is laid in the ground. If you pause, you do. It's time for me to do now. Perimeter of the grass. Now this is by no means an easy question. It requires a fair amount of thinking to pull this off. What did we build? 20. I have x to take away. I have x take away to get this length. So that length there is going to be 20 take away x, or 20 take away 2x. That is going to be the width of the grass. Now for the length of the grass, again, we're working on the premise that it's x, because they don't tell you, but we'll work on that premise. Then it's going to be x. It's going to be x'd out, which means that you have 30 take away 2x. 30 take away 2x. Okay, so I can write now that for the grass, the length. So I've done those calculations, and what we have is the length. L is equal to 30 take away 2x, and then W is equal to 20 take away 2x. Okay. Now the perimeter. How do I find the perimeter? Well, let's do the area first. I think the area is easy, because the area is equal to length times width, which in this case is 20 minus 2x. And you have to put it in brackets to get the multiplication done properly. Non-negotiable, must put it in brackets. Multiply by, that's 30 take away 2x. The order we put them in doesn't matter, but that's the answer. You should get 20 take away 2x by 30 take away 2x. The perimeter requires a bit more work. That's why I left it for last, because I have to do the adding. I have to do for the perimeter, we're doing 20 take away 2x plus 20 take away 2x plus 30 take away 3. What am I doing? 30 take away, where are we? 30 take away 2x plus 30 take away 2x. What do we have there? We have 20 and 20 and 30 and 30. That is 100. So we're getting 100 there. I'm going to write it a bit cleaner. We're going to write it at the top here. So we're getting 100x. Wow, never saw that one before. 100x. You ever dealt with 100x before? Wow. And then, and maybe because it's not x's, it's 100. What am I doing? 100. If you haven't realized it, it's very, very early in the morning and the brain is not firing on all cylinders. That's what's happening here. So we have 20, 20, 30, and 30. That's 100. And then the other bit we're looking at is the x's. I have minus 2x, minus 2x, minus 2x, minus 2x, minus 2, minus 4, minus 6, minus 8. The answer, 10x minus 8x. So the answer for this question, 10x minus 8x. And, whoo, We are almost here. We are almost here. Here is the last question for us to try. P10 in this task 36, constructing formulae. So doing constructing simple formula. This is the last one we want you to look at here. Almost there. Almost there. Okay. Right, so it's the age. So you paused, you had to go, and you want to set up the ages now of these two folk. We want to set up the two ages. Rebecca is a year older than Ben, and we've told what we have is Ben's age is X. If Ben's age is X, then Rachel, is 1 year older than Ben, so Rachel is X plus 1. Ben is X years old, Rachel is X plus 1. Emma is 3 years younger than Ben, so I start off at Ben's age. Let's say if Ben was 10, then you'll tell me that Emma is 7, so you're taking away 3 from Ben's age. So I start with Ben's age, X, and I have to take away 3. That's her age. So Rachel's age is X plus 1. Emma's age is X minus 3. The sum of all of their ages is going to be X, Ben's age, plus X plus 1. Rachel's age plus X, take away 3, which is Emma's age. Simplifying expressions, X plus X gives me 3X. And then positive 1, take away 3. On the number line, I start at 1, I take away 3, I will get down to minus 2. So the sum of all their ages, which we can call S is equal to 3x take away 2. 3x take away 2 is what we have. Okay, so 3x take away 2. And that is it for task 36. That is it for constructing formula. Changing the subject of a formula or rearranging a formula, that's the big one, really. We've looked at constructing the formula, we've looked at substituting the formula, and then let's look at this situation where, for example, if I gave you the formula for finding degrees Fahrenheit, and it's presented here as F is equal to 1.8 C plus 32. And reading through that, F is for Fahrenheit, C is for Celsius, two different ways of measuring temperature. F is 1.8 times the degrees Celsius plus 32. What if I gave you the degrees Fahrenheit and I wanted to find degrees Celsius? How do I make C the subject of the formula? Really, really, really useful technique to have to be able to make that rearrangement. Let's explore how we do that for this formula and for others, and then you'll have a chance to practice some. So we have F is equal to 1.8 C plus 32. We want to rearrange that to make C the subject. Making C the subject, what I mean is that at the end of this process, we will have C is equal to. Now, it's really important to understand and appreciate that I said C is equal to, but C can either be on the left-hand side of the equal sign, or the right-hand side. It does not matter. That's really important. And generally, or not generally, but in many cases, in this particular case, what you'll find is we'll end up with C all by itself. That's what we mean by making it the subject. The C is all by itself on one side. No numbers, no letters, no. It's just C on one side, just as F is all by itself on one side. That's what we want to achieve. And if it's on the right-hand side, job is done. But if you want to make it prettier, stick to convention of having the subject on the left, then we can just swap everything over at the end. It's fine. But let's go through the process. And the process is change side. This has worked for me throughout. It's not what you might see in many textbooks, but this idea, keep this one big idea in your head, and it will make a huge difference, I say. Change side, change sign. Or if you don't want to use the word sign, it fits better, but change operation. And you'll see what I mean. I want C all by itself. So I have F is equal to 1.8 C plus 32. I want C all by itself. And by the way, if you think you know what to do, then do it. Get on and move through the video at the pace that's right for you. That's important as well. I want C all by itself. And that means the plus 32 needs to go. It's the first thing that needs to go. And it's on the right hand side. So the equal sign is in the middle, and we have what's the F is to the left, 1.8C plus 32 is to the right. And if I want C all by itself, it's going to end up by itself on the right hand side, then plus 32 has to go on to the left hand side. And the rule is if you change the side, you have to change the sign. So plus 32 on the right has to become minus 32 on the left. So I can now write as my first line that F take away 32, F minus 32 is equal to 1.8C. What have I done? I've moved the plus 32 from the right hand side to the left hand side. Now for the second phase. Remember, we want C all by itself. We don't want 1C, 2C, or in this case 1.8 multiplied by Cn. It's really important to remember that's the operation here. 1.8 is being multiplied by C, or C is being multiplied by 1.8. Order doesn't matter. And the rule, we apply the rule again. If you change the side, and 1.8 cannot stay on the right, it has to go on the left hand side. So I have to change the sign. And at the moment, what do I have on the right hand side? I have C is being multiplied by 1.8. So if it's multiplied by 1.8 on the right, when it goes to the left, it has to become divide. I need to use the inverse operation. We'll all change the side, change the sign. The spirit of it is when you move over, you do the opposite operation. So what's plus becomes minus. What's minus becomes plus. What's multiplication becomes division. The entire right-hand side, so all of F take away 32 has to be divided, and we'll use a fraction line to represent division, by 1.8, and that will give me C. What happened? C is being multiplied on the right hand side by 1.8. We want C by itself. We don't want 1.8C, we just want C. So the opposite of multiplication, we move the 1.8 to the right hand side and it becomes divide. So the entire left hand side has to be divided by 1.8. And as I told you, see what happened here where C is on the right hand side. If you want, and it is, I suppose, it's good practice, I suppose, we can swap over the sides at the end and say C is F, take away 32, divided by 1.8. We do not have, at that last stage, we don't have to change any sides or signs. The reason we don't have to change anything is because we're just doing a like-for-like swap. Okay, I'll leave it at that for simplicity, okay? There you go. You have a formula. C is your subject of your formula. Let's look at a couple others using this idea. Change the side, change the sign. How about we now make V the subject of the formula? Let's work through this one. Even better yet, how about you work through it? You do it. I'm going to show you. I'm going to do this twice. So get started, pause, have a go, use the power of the pause. In terms of me, or if you prefer at this stage to work through it with me, okay, that's fine. You have the exercises to do after, okay? Now I'm gonna do this twice because there's two different ways we can do it. The first way, I want to end up with V all by itself. V becomes the subject, and what I'm gonna do is I'm following my rule, change the side, change the sign, or change the operation. And just remember, let's see what we have set up here. We have a left-hand side and we have a right-hand side. I want V all by itself. That V is going to end up all by itself. At the moment, the V, it's in a bracket. It's being multiplied by T and it's being divided by 2. We need to get rid of that dividing by 2. So dividing by 2 on the right has to become multiplying by 2 on the left. My first line, my first step I'll write is 2s is equal to, I should write in blue. Should I write in blue? Yeah, I'll write in blue. Okay, right. So first bit I'm writing is 2s is equal to u plus v multiplied by t. So the divide by 2 has become multiply by 2. Then the next bit is at this stage. This is a big moment because there's two directions you can go here. You have two methods you can end up with. One of the ways is you can expand the bracket, but I'm not going to expand the bracket. And this time around, I'll do it next, and you'll see what will happen. At the moment, the expression in brackets u plus v is being multiplied by t. It's being multiplied by t, and the opposite of multiplying by t is dividing by t. So that multiplication by t, it has to go over to the left. It's on the right, it has to go over to the left. And if we change the side, we change the sign. So multiplication becomes division. So I now will write 2s, and it's now divided by t. So the multiplication by t is now division, is equal to u plus v. Now, because it's no longer being multiplied by a term on the outside, there's no need for the brackets. So brackets are gone. It's just u plus v. But we don't want u plus v. We want v to be the subject. We want v to be the subject all by itself. So our current situation where we're adding u, that needs to go on to the right-hand side. And if it goes on the right-hand side, change the sign, it's going to become negative. So what are we going to have? We're going to have 2s divided by t, and now take away u, that is going to be equal to v. So that's the third step. 1, 2, third step, we move there. And, well, now we want to beautify. That's the way I'll put it. We want to beautify. In other words, we just want that convention where v is on the right-hand side, left-hand side, the subject is on the left. It looks prettier. Our brain feels more comfortable. V is equal to 2s on t, take away u. And that is us sorted. I'll put that in a nice box. Yay, that looks pretty. That's us there. And we have a solution there. Now, what would have happened, and I want you, again, if you did you do it this way, or I'm assuming, I'm working with a premise, you had to go. You had to do it. Yeah, you couldn't wait on the teacher. You just got stuck in. That's what I like. I love it. But if, what would happen, or what did happen if you did it like this, if you expanded the bracket? It's not going to look like this. Or well, but is there going to be a problem? Let's see what happens. So down on the right-hand side here, I'm going to, after step 1, I'm going to write it in. So what do we have? We've decided we have 2s. I'm going to write it in. I'll do green this time. So we know we have 2s is equal to u plus v being multiplied by t. Let's expand the bracket. So let's not go down this pathway. Let's expand the bracket now, and let's see what happens. So I'm going to multiply out. So what do I have? The u multiplied by the t, and then the v multiplied by the t. And that will give me 2s. Ooh, well, let's stick with green. Whoa, ooh, la 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 la. Let's say 2s is going to be equal to ut. U multiplied by t is ut plus v. T plus vt. I want v all by itself. So at the moment now we're adding ut. That plus ut needs to go on the left, and it's going to become minus t. So in this current version, we now have 2s take away ut is equal to vt. And I should have put that to take away ut in red so it's clear that is take away ut is equal to vt. And then from there, well, I want v to be the subject, and v is being multiplied by t. I don't want it to be multiplied by t, so the multiplication by t needs to change the side, and if it changes the side, it changes the sign. You're expert at this. You're expert at this now. So it has to become divide by t on the left-hand side, and at this stage, I'm going to get some more space on my screen. The last line we're going to have there is 2s take away ut, and now it's going to be divided by t is equal to v. And you're thinking, well, hang on, hey, that looks different to what we had. Let's put the pretty version in the middle. So in the green corner, when we did it in blue, we had v is equal to 2s on t take away u. When we do it in green, we get v is equal to 2s take away ut divided by t. So the entire numerator is being divided, and it's being divided by t. And let's put that in the green rectangle. Let's say in the green rectangle we have blah, 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 blah. I can't make it bigger. Come on, let's do this bigger. In the green rectangle. Wow. Okay, now that looks cool. That looks cool. So those are the two solutions. Are they different? Are they different? We used a different method. We expanded the bracket in one approach. We didn't expand the bracket in the other approach. Doesn't matter. Now, in both cases, we have V as the subject. And if we were to do a bit more work, we do not have to. Really important that I say this. There is no requirement to go any further in terms of that formula in green. But if we did a bit more work on it, you will see we will get the same as the formula in blue. Look at what would happen. I'll just write it at the bottom here to finish. If we separate the fractions, we have 2s divided by t, take away ut divided by t. That's what will happen. If we separate the fractions, the first term on the numerator, take away the second term on the numerator. And look at the second term, what happened. Now we have the first term matching the blue, 2s on t, and the second term, well, hang on, I have t divided by t. When you cancel out the t's, it's just minus u, the same as the blue. Got that? Minus u, the same as the blue. Slick. Okay, you got it. You're with it there. So different methods, and what I'm really important to show that you can expand the bracket. You don't have to. You decide it's all. Sometimes it's about how you're feeling at the moment, but you decide on your strategy to change the subject, and it might mean sometimes that your answer, the format looks different. Being different, a different format does not mean it's incorrect. Both of these formulae are correct. We have changed the subject successfully. So just bear that in mind. Bear that in mind. And I've shown that additional step. So even if you have an answer that looks different to the answer provided, maybe if you are correct, you should be able to do a bit more extra work doing the separating the fractions, for example, and you should get a match. Okay, great stuff, great stuff. Now we got to practice some of this stuff. Hopefully you've done this one. And now, whoa, that was for me doing it a second time, but I did all of it on one page, which I think was a bit better, way, way, way better. So let's go. Here are some questions for you to do. Now, there are 4, 5, 6, 7, 8, 9, wow, 10 questions that I'm just looking through how much I have here. We're gonna, I'm conscious of time. If you want to do all of the questions, so there's actually 10 parts as I just showed you. If you have the time to do all, great. If you don't, 2 of each. I'll point out, so the critical ones, if you don't have the time, the more you do, the better. But I understand, I just want you to do these last 2 if you don't have the time. Actually, no, not those last 2. We'll do D. If you don't have the time, you're just doing D and J. So off you go. Pause and have a go. I'll provide the answer to all of them. Now for the solutions, I had my pen upside down. Won't write like that. For A, you have x is equal to y on 4. For D, you should have x is equal to 4y, take away 2. For G, where is G? X is equal to y, a plus b. D and G, it's the same logic. It's just getting comfortable with the idea that it can all be letters. That was the bit there. And the same thing for J, a bit more complexity in J. And for J, you would have that x is equal to yb plus c divided by a. So yb multiplying, then adding to c, then dividing by a. Those are your 4 answers there. Please mark your work. Mark your work. And we have to move on. Here are 3 questions for you to do. Make x the subject of the formula. So x is the boss. I can make that a bit bigger. Yes, I can. X is the boss. I want x equals. Off you go. Pause and have a go. If, as I said, if it is that time, you're pressed for time, I just want you to do you. Just try you, okay? Great. Have a go. Okay, and now we want to give the answers to these. I need to make sure I'm looking at the right questions, which might not always be the case. Okay, right, I found it. Okay, right, so what do we have? For S, you had your moment, you did the power of the pause, you're ready for answers to mark your work, great stuff. For S, you have X is equal to 2Q divided by 3 plus 4. That's one way. I imagine you might have been able to write it differently. You might have something with 12, maybe. I'm just saying if you expanded the bracket, but that's your challenge there to see if your answer is the same. For T, X is equal to 4V divided by 5, take away Y. And the big one, the one that I asked for everybody to do, U, X is equal to 4 Z mine. Oh, I'm not going to have enough space for this. I'm going to write it above. Sorry. It's not going to happen there. For you. Did you get that? For you. This is just for you. Oh, for you. For you. I did it for you. At a moment, I did it for you. And the answer for you. Oh, can I do it again? All right. I won't do it again. I won't. I ain't gonna do it again. Good. For you, we have X, and I'm just thinking my well, see lots of complications in the space here. I just clicked on me that that's where I put the picture goes there in the edited video, in the composite video. Sorry, it's not really edited. X is equal to 4 Z take away A plus 3. That's the answer you should have. X is equal to 4Z take away A plus 3. So we got there in the end for that one. And let's go on. All right, let's go on. We move on. For these, if you press for time, just do A. Just do A. If you press for time, just do A. But brilliant if you can do A and B. A and B would be perfect. If you press for time, just do A. That's what we're looking at there. So you've had your moment, you had your power the pause, and the answers are coming. A is going to be equal to V squared minus U squared on 2S. By the way, these two formula, if you do mechanics, A-level maths, mechanics, applied maths, you use these formula. These are very, very, very heavily used. Part of what we call the SUVAT equations for kinematics. Constant acceleration equations. So A is acceleration, T is time, U is the initial velocity of a particle, V is the final velocity, S is displacement. Displacement is distance in a given direction, so it's a vector, not a scalar. You see, I started using yeah, you're going to learn all of that in A level, don't worry. And for the last one, A, if you want the acceleration, it's a lot easier just to talk. I'm trying to find the acceleration. I want the displacement. S is for displacement, not speed. Get with it. Show off with your friends. Say, hey, do you know this formula? It's one of the SUVAT formula for dealing with looking at kinematics, movement, motion under constant acceleration. Do you know what S stands for? And they'll say, sure, I know, it's speed. And you'll say, no, it's displacement. And they'll be like, and now explain what displacement is. Do you remember? Distance in the stated direction. T plus a half t squared is what you'll be dividing by. If you feel uncomfortable with putting a half t squared down there, you can put 0.5. That would do the job as well. Okay, right. So we have those, and we are almost done. Oh, time flies when you're having fun. Last question. Here you go. I want you to try this with the. I'll really like you to try this. Okay. If it is, again, if you press for time, etc., it might be that you, for example, you leave this and you do it in your next session. The next session you're getting together if time is an issue. But I really want you to try this question. I think this is quite useful to try this one. Okay, so really great if you can finish it now. If it is that it needs to wait until the next time you do your maths, that's fine. Okay, so off you go with problem number 4. And I will put in the answers for A and B as soon as I can find them. I lost myself, so I was lost, but now I am found. Okay, right, 2A, right. Write a formula. A is as the subject, so what you can have is that A is equal to 2A on H take away B, so 2A on H take away B. And then in the particular situation they have given you, use this to write a formula that does not involve B and make A the subject. 2 bits, I'm going to give you what that formula should look like. See why I asked you to do this? This was a beautiful one, wasn't it? A beautiful one. I am happy to, I am at some point I'll do a video going through this in detail, but at the moment I'll just give the answer for it. So for B, your answer, the formula, what you're starting off looking like is we would have had A is equal to half times 3A times H, which is equal to 3AH on 2. So what we're saying, just to make it really clear, is that A is equal to 3AH on 2. And then if I rearrange to make A common A, small a, and this is a really important point. Capital letters and common letters can have different values. You can use capital A and common A. They're not the same value. Okay. And in this particular case, it would mean that A, which is what you were asked to make the subject, make A small a, common A of the subject. A is 2A. So your final answer, A is 2A on, what is it? 2A on 3H. So that is the answer you would have had as your final answer. A is 2A on 3H. That's the one you should have had. And I've given you, yeah, that's visible there. Okay, right. So that's the solution. Part B, this is a big one, and that is task 37 done. Task 37 done. 37B actually, because there's a different version of this, but this one is targeting the more complex formula, and even more complex formula is what's going to be in 38. Is 38B or 39? I need to check my references, but yeah, we'll go at 38B, 38B. We'll go at 38B. That's what you want to look at after this 38B. Hope so.